I also wanted to kind of pick your brain a little bit about uh, the funding justifications for some research projects. So I
Ah,
don't know if you know, there's like a famous Sarah Palin quote where she
yeah,
criticized the fruit fly research, and you've admitted before that you didn't go into this experiment knowing that a Nobel Prize would come out of it or that human
yeah,
applications would flow out of it either. I think often, I study riboswitches, switches, and I imagine my PI has to say a lot, these have potential applications in antibiotics. But
yeah.
really, sometimes I think he just really likes the science of the RNA world.
He
Um,
better.
yeah. Um,
Right.
and do you think, this is interesting biology is sufficient research justification, or is,
Well, it's a problem, it's not, um, it's other people's money
mhm,
being spent. And I think the it's not up to us so much to decide as the other people. And so people who have jobs that aren't so exciting and look forward to 5 o'clock and being able to go home pay taxes, and there's a general consensus that some fraction of that money should go to support science in this country. And I think what you want people to believe is that, and what has historically always been true, is that if you have people doing science, that you can't predict the outcome, but that good things and valuable things in some come from that research and that it pays off. It's interesting. When I was visiting China a couple of years ago. I was meeting with some higher up political political science figures, and the big thing that they wanted desperately from me was to know how they could plan or instruct their students or their scientists to do experiments that would gain Nobel prizes for China. And uh, it's, I mean, that seems, I can understand how, people would think that way, or we could say, but that's another version of how can we instruct our scientists to do experiments that are going to cure cancer.
mm,
It is the, I think the better awareness is that it's wise to, to, to give as much, and science is competitive, and we do have to judge, and not everybody's going to get money, and you have to make these choices, but to have it based on what scientists find as interesting and worth pursuing is the better financial bet. I think, but people whose money it is aren't going to feel that way quite, and so there's always this balance between what you know they could buy into that and say, yeah, well, let's give some fraction of it for basic research, and let's give a big bulk for something where we can see a practical outcome. And I'm all in favor of that because uh, people suffer from cancer, and and so if we can figure, there's some kind of balance there. It's um, it's just hard though because from a practical standpoint, if you're trying to predict ahead of time what you're going to get out of it, the odds are that you're not going to be doing a very good experiment, or that most of the experiments you're doing are going to be so limited and artificially designed that it's hard. You don't that you could be more profitable to take a route that wasn't so directed and specific. I mean, it's the same thing as if you believe that molecule A is important, you can invest all your energy into it, or you can do a genetic experiment, find out, let's look at all the molecules and find out which is the one that is actually important. One of them is a kind of a more basic research type question.
Right. That's really fascinating. So, I mean, I wanted to discuss a little bit, sort of, and I'm sure you've been pushed to talk about this beyond your breaking point, but the science of what, what contributes to a breakthrough, and not in, the Chinese governmental official sense of, how do we get our scientists to make breakthroughs, but because I don't know that it's possible to say, if you learn science in this way, you will make a big breakthrough. If you think of
Mhm.
like CRISPR, I don't think anyone expected, a really important gene editing therapy to come from a bacterial immune system.
Yeah,
Um, so, but do you think that there are elements of, that make science conducive um, to to really important and high impact, or is it really just things kind of pop up when you're doing good work?
I think a fair measure, it was not an infallible measure, but a fair measure is if you can get other scientists to be interested in what you're doing. And so when you talk about things, if you can't get anybody to be interested in what you're doing, scientists whom you respect, and there's so many smart scientists out there that if you can't uh, get anybody to be interested in it, then it seems to me uh, you're going to miss out on the one thing that guarantees success, which is the community of scientists beating their heads against the wall and against each other's heads to to figure out how things work. And so a constant test, and this is why I think peer review and many things like that work as well as they do, is that the way of predicting what's going to evolve into something that's useful or valuable is if many scientists, is if something that scientists find interesting from a variety of different perspectives. And so if the physicist and the molecular biologist and the genomicist find the mechanics of transcription factor binding to enhancers in concentration dependent ways interesting, then the odds are that there is something interesting there. And if enough smart people, so I'm very much of a very socialist view of how science works, or social view of how science works.
That's interesting. I mean, not to not to be too confrontational, but it makes me think of uh, your partner in this experiment. I'm gonna mispronounce her name, but Christiane Noslin Wolf
Yeah, yeah,
said once, I think, that they presented some of her work on a poster, and some top scientists came by and were like, didn't really get it, didn't really see the
yeah.
impact, and left. And um,
Yeah, that's true. That's true for individuals. But if she's going to compete, a lot of people she talked to found everything she was doing really interesting. And so, the particular individual top scientist can be a fool.
right. I think it's probably also complicated a little bit by the fact that, and you've said this a number of times, is that the importance of the science you do is defined later by how much it's followed up on. So it's hard to say. I mean, maybe there are potential breakthroughs that were simply never followed up on. CAR
No,
T is not a new technology.
yeah,
Immune engineering is actually decades old, but now recently has been followed up on.
it's all that's true. It's but doing science in that way is kind of like what what they say about democracy, that it's a terrible government system, but it's the only one that is better than any of the others. And so the way we do science, it is true that you can find flaw, you can find historical failures to appreciate something that was truly insightful, but you know your job as a scientist is to interest other people in what you're doing. I believe that. I believe you have that obligation as a scientist.
Hmm.
You have to be able to stand up and talk to other scientists. Or if you aren't able to do that, that's a debit. something that is I don't know how you talk about these flaws, or it's something that if you didn't have that, you would be a better scientist. You could talk to people, yeah, because so much of science is really related to that being able to talk to other people and then have this emergent group effort where finally we understand CRISPR, not because the original people necessarily understood CRISPR in this way, but in all of its potential. But because everybody, it is that if you can't achieve the community interest, then things are going to be likely stuck back in square one.